This is Bitnar Talks, the engineer takes on construction. Episode 27. Hi, I'm Piotr Bitnar. Each day I help my clients plan and design building projects through Bitnar Limited, a consulting chartered structural engineer's practice. My biggest passion and the cornerstone on which I've built my business is finding clever solutions for construction projects. I am a chartered structural engineer and a budding software developer, so you can rest assured that I will strive to talk about the best practices and the use of new technologies in the industry. And if you're embarking on a construction project or are involved in planning, designing and building the world around us, you'll find this podcast useful. Approved Document L, Conservation of Fuel and Power Volume 1, Dwellings. Hi, and welcome to Bitnar Talks, your favorite podcast on all matters of architecture, engineering and construction. It is Thursday the 22nd of August 2024, and I'm here back with you with the 27th episode and information on Approved Document L, Conservation of Fuel and Power Volume 1, Dwellings. I think the weather is more patchy this year than my delivery of this podcast. At least you can tell it will be released once a week, well, usually. But with what is happening outside of the window, you damn sure cannot. Anyway, when the weather turns cool, I'm all more happier to sit behind a microphone and deliver new content for you. Especially this one that is rather long, and that is why it is delivered at a fortnight since the last one. Once I got to this, I just could not stop and make it in parts as I did with Approved Document B. As ever, before I go to covering the material of this episode, let's have a look at what was covered last week. In the last episode, I talked about the Approved Document K, protection from falling, collision and impact. There are 6 requirements covered in this document, contained within 10 sections, and these sections are as follows. Section 1 deals with stairs and guardings, where minimum safety standards dictate the design of stairs, concentrating on consistent step geometry, proper riser dimensions and secure handrails. Different requirements apply to private homes, public areas and industrial buildings. In Section 2, which deals with ramps and guardings, we found out that ramps must meet specific gradient and width criteria, with mandatory landings and protective barriers to ensure accessibility and safety, especially in non-residential settings. Section 3 treats on protection from falling, where we are told that guardrails are required in areas with fall risks, like stairs and balconies, with specified height and strength standards. Additional safety measures may apply to maintenance areas. Section 4 emphasizes vehicle barriers and loading bays, that indices should be strong enough to mitigate on vehicle collisions, and loading bays should have safety exit points or refuges to protect workers from impact from delivery lorries. Section 5 deals with glazing safety, where standards for glazing focus on impact resistance and the safe use of different glass types. Protective barriers may be necessary to prevent injuries. Section 6 treats on collision with open windows, especially in non-residential buildings where barriers or other methods to prevent people from colliding with open windows need to be put in place. Section 7, glazing manifestation, tells us that large transparent glass in public spaces must be clearly marked at specified heights to prevent accidental collisions. You know, those little greyish on semi-transparent dots, stripes or whatnots. Section 8, safe operation of windows, simply tells us that windows in non-dwellings must have reachable controls and protective measures to safely operate them and prevent falls through open windows. Section 9, access for window cleaning. In non-residential settings, these must ensure safe access for window cleaning, including limits on reach and provisions for safe ladder use. In Section 10, in doors safety, doors are especially in the residential buildings, must include safety features like vision panels and mechanism to prevent injury from sliding or swinging on or falling a chair. In this episode, I will move to the approved document L, Conservation of Fuel and Power, Volume 1, Dwellings. So without further ado, let's dive straight into this. In this episode, I will talk about the statutory guidance contained within the approved document L, Conservation of Fuel and Power, Part 1 or Volume 1, Dwellings. The requirement L are short and sweet and only 2, but that is further expanded by 19 different additional regulations, including Regulation 6, some regulations from Part 6 of the building regulations, as well as Part 8 and Part 9. There will be plenty of talk in this episode, so buckle up, Dorothy, because Kansas is going bye-bye. The episode will follow the structure of the approved document from Section 0 to Section 12 and all the additional regulations along the way as laid down in the document. So let's get into the nitty-gritty of this approved document. Starting with the text of the legislation. Part L, Conservation of Fuel and Power. Conservation of Fuel and Power, Requirement L1. Reasonable provision shall be made for the conservation of fuel and power in buildings by A. Limited heat gain and losses. I. Through thermal elements and other parts of the building fabric, and 2 I's from pipes, ducts and vessels used for space heating, space cooling and hot water services. B. Providing fixed building services which I. Are generally efficient to a reasonable standard. II. Have effective controls, and III. Are commissioned by testing and adjusting as necessary to ensure they use no more fuel and power than is reasonably in the circumstances. And requirement L2, on-site generation of electricity, where a system for on-site electricity generation is installed. A. Reasonable provision must be made to ensure that I. The system and its electrical output are appropriately sized for the site and available infrastructure. II. The system has effective controls, and B. It must be commissioned by testing and adjusting as necessary to ensure that it produces the maximum electricity that is reasonable in the circumstances. Okay, so these are the paragraphs of the legislation requirements contained within its Schedule 1. There will be more regulations popping in as we go along, so let's take it slow and methodically as laid down in the approved document. Section 0 gives us a little bit of an introduction to the whole lot. You already know that today we talk about dwellings, and there will be a second part coming dealing with the buildings other than dwellings. We are reminded that dwellings are considered to be self-contained units, and if these form flats, we are told that common areas for like heated corridors, we need to consider appropriate measures as for the dwelling itself, but for unheated space, the fabric elements need to meet minimum standards. Section 1 to 9 deal with new dwellings. Conservatories in such new dwellings are considered separate if they are not heated and thermally separated from the house. If not, it will need to be considered as part of the dwelling necessitating primary energy rate, emission rate and fabric efficiency rate calculations, as is the case for the house. Extension to and work on existing dwellings will follow the consideration of heat gain and losses from Section 4, building services consideration in Section 5 and 6, and new and improved thermal elements in Section 10, 11 and 12. As ever, listed and historical buildings will be treated ever so slightly differently. If we can upgrade a thermal element, we ought to, but it is recognized it is not prudent to force it on all such buildings. Conservatory and porch type extensions are also exempt under Regulation 21 if the extension is at ground level, under 30 meters squared, the glazing complies with requirements K, divided from the building with an appropriate wall, door or window, and the heating system of the house is not extended into that space. Carports and otherwise covered areas are exempt from the regulations if under 30 meters squared. The workspace within a dwelling should be treated as a dwelling if the commercial use can be reverted into a dwelling. The approved document L will have some interactions with other documents like Part C, E, F, J, K and M. Now, a very important part of the whole consideration is the energy performance calculations for the dwellings, and these are contained in regulations 24, 25, 25B, 26, 26A and C, 27 and 27.8 as well as 27C. I will now go on to read you the text of them all so you can return back to it whenever you want. Methodology of calculations of the energy performance, Regulation 24.1. The Secretary of State shall approve a methodology of calculations of the energy performance of buildings, including methods for calculating asset ratings and operational ratings of buildings, and b. ways in which the energy performance of buildings, as calculated in accordance with the methodology, shall be expressed. 2. In this regulation, asset rating means an energy performance indicator determined from the amount of energy estimated to meet the different needs associated with a standardized use of the building. And operational rating means an energy performance indicator determined from the amount of energy consumed during the occupation of a building over a period of time and the energy demand associated with a typical use of the building over that period. Regulation 25, Minimum Energy Performance Requirements for New Dwellings. Minimum energy performance requirements shall be approved by the Secretary of State, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24 for a. New buildings, which shall include new dwellings, in the form of target CO2 emission rates, b. New dwellings in the form of target fabric efficiency rates, and c. New buildings in the form of target primary energy rates. Regulation 25b. Nearly zero energy requirements for new buildings. Where a building is erected, it must be a nearly zero energy building. Regulation 26, CO2 emission rates for new buildings. Where a building is erected, it shall not exceed the target CO2 emission rate for that building that has been approved pursuant to Regulation 25, applying the methodology of calculation and expression of the energy performance of buildings approved pursuant to Regulation 24. Fabric energy efficiency rate for new dwellings, that's Regulation 26A. Where a dwelling is erected, it shall not exceed the target fabric energy efficiency rate for the dwelling that has been approved pursuant to Regulation 25. Applying the methodology of calculation and expression of the energy performance of buildings approved pursuant to Regulation 24. Target primary energy rates for new buildings, that's Regulation 26C. Where a building is erected, it must not exceed the target primary energy rate for the building which has been approved pursuant to Regulation 25C, applying the methodology of calculation and expression of the energy performance of buildings approved pursuant to Regulation 24. CO2 emission rate calculations, that's Regulation 27.1. This regulation applies where a building is erected and Regulation 26 applies. Point 2. Not later than the day before the work starts, the person carrying out the work shall give the local authority a notice which specifies a. The target CO2 emission rate for the building, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. b. The CO2 emission rate for the building as designed, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. And c. A list of specifications to which the building is to be constructed. Point 3. Not later than 5 days after the work has been completed, the person carrying out the work shall give the local authority a notice which specifies I. The target CO2 emission rate for the building, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. I. The CO2 emission rate for the building as constructed, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. And I. Whether the building's has been constructed in accordance with the list of specifications referred to in paragraph 2c, and if not, a list of any changes to those specifications, or B, a certificate of the sort referred to in paragraph 4, accompanied by the information referred to in subparagraph A. Point 4. A local authority are authorized to accept, as evidence that the requirement of Regulation 26 have been satisfied, a certificate to that effect by an energy assessor who is accredited to produce energy performance certificates for that category of building. And point 5. In this regulation, specifications mean specification used for the calculations of the CO2 emission rate. Fabric energy efficiency rate calculations, that's Regulation 27A. Point 1. This regulation applies where a dwelling is erected and Regulation 26A applies. Point 2. Not later than the day before the work starts, the person carrying out the work shall give the local authority a notice which specifies A. The target fabric energy efficiency rate for the dwelling, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. B. The fabric energy efficiency rate for the dwelling as designed, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. And C. A list of specifications to which the dwelling is to be constructed. Point 3. Not later than 5 days after the work has been completed, the person carrying out the work shall give the local authority a notice which specifies I. The target fabric energy efficiency rate for the dwelling, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. I. The fabric energy efficiency rate for the dwelling as constructed, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. And I. Whether the dwelling has been constructed in accordance with the list of specifications referred to in paragraph 2c, and if not, a list of any changes to these specifications, or B. A certificate of the sort referred to in paragraph 4, accompanied by the information referred to in subparagraph A. Point 4. A local authority is authorized to accept, as evidence that the requirement of Regulation 26A have been satisfied, a certificate to that effect by an energy assessor who is accredited to produce energy performance certificates for that category of building. And point 5. In this regulation, specifications mean specifications used for the calculations of the fabric energy efficiency rate. Now off to Regulation 27C, target primary energy rate calculations for new buildings. Point 1. This regulation applies where a building is erected. Point 2. Not later than the day before the work starts, the person carrying out the work must give the local authority a notice which specifies A. The target primary energy rate for the building, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. B. The calculated target primary energy rate for the building as designed, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. And C. The list of specifications to which the building is to be constructed. Point 3. Not later than 5 days after the work has been completed, the person carrying out the work must give the local authority A notice which specifies I. The target primary energy rate for the building, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. I. The calculated target primary energy rate for the building as constructed, calculated and expressed in accordance with the methodology approved pursuant to Regulation 24. And I. Whether the building has been constructed in accordance with the list of specifications referred to in paragraph 2c, and if not, a list of any changes to those specifications, or B. A certificate of the sort referred to in paragraph 4, accompanied by the information referred to in subparagraph A. Point 4. A local authority is authorized to accept, as evidence that the requirements of Regulation 26C have been satisfied, a certificate to that effect by an energy assessor who is accredited to produce energy performance certificates for that category of building. And point 5. In this regulation, specifications mean specifications used for the calculations of the target primary energy rates. So what are these all about, you ask? In the opinion of the Secretary of State, the building is nearly net zero energy building if it meets the target emission rate required by Regulation 26, and it is analyzed if alternative high efficiency systems could be used and be feasible for the building. Analysis in line with Regulation 25A. Regulation 24 simply tells us that the Secretary of State needs to approve a methodology of assessment, and this is widely known as the Standard Assessment Procedure, otherwise known as SAP in short. Regulation 25 requires the Secretary of State to approve minimum targets for primary energy rates, emission rates and fabric energy rates, and these rates calculations will be needed for the new dwelling in line with the Regulation 26, 26A and 26C. Regulation 27, 27A and 27C cover the notification of building control of the calculation both prior and after the building is built. So, Section 1 is all about calculating the target primary energy rate, target emission rate and target fabric efficiency rate, so-called total energy performance. It is done by comparing the calculations of the actual dwelling against so-called notional dwelling, before and after the construction. A notional dwelling is simply the proposed dwelling in shape and size, but with the accepted performance of fabric and services, and as such the building needs to hit that minimum in the specification. The government set out the standard assessment procedure, SAP in short, to deal with that requirement. The target primary energy rate is measured in kilowatt hours per meter square. A target emission rate is measured in kilograms of CO2 per meter square. The target fabric energy efficiency rate is measured in kilowatt hours per meter square. The full spec of figures used in SAP can be found in the SAP Appendix R. So every new dwelling will need to have these parameters calculated using SAP. It typically means that thermal fabric opening area should not exceed 25% of the total floor area, walls to have a U value of 0.18 watts per meter square per Kelvin, except the party wall where this is 0. Floors are at 0.13 watts per meter squared Kelvin, roofs at 0.11 watt per meter square Kelvin, roof windows between 1.2 and 1.7 watt per meter square Kelvin, depending on an angle of the roof window. Windows and doors at 1.2 watts per meter square Kelvin when more than 60% glazed area, otherwise 1 watt per meter square Kelvin. Air permeability at maximum of 5 meter cubed per hour per meter square at 50 pascals, with natural ventilation and intermittent extract fans. And further minimum specifications for heating source, whether a gas, heat pump or network different heating system and hot water systems including heat recovery. Lighting with maximum total capacity of 185 times the floor area in lumens with efficiency of 80 lumen per watt at the requirement for PV systems of at least just over 6% of the ground floor area in dwellings, and similarly for flats only times the number of stories. Installation facing southeast to southwest. All these ratings, when taken for a building containing multiple dwellings, typically flats and terrace houses, we can do a weighted average of values by simply adding all the targets and dividing them by the sum of all floor areas. Now section 2 deals with calculations of the actual project. Dwelling primary energy rate, dwelling emission rate and dwelling fabric energy efficiency rate. All these needs calculation before the project starts and then compared with what has actually been built and in correlation with the air permeability of the building. The building control body needs notification on all these rates and how they compare between the target and design values and what specification has been used in the calculation. That can be done using BREL report, that is Building Regulation Part L Compliance Report, which is shown in Appendix B of the document. And the notification needs doing before shovels hit the ground, and then again with the build values and photographic evidence following the construction. When the building contains a number of units, we can either use each unit value on its own or the averaged values for all of them. The emission value and primary energy rate calculation may be complicated a bit further with a use of additional heating source, and the value should be reached by considering the percentage of the input of the two different sources serving that space. For heat networks, we need to calculate the CO2 and primary energy factor to use in our calculations, and the factor will equally apply to target and designed values. And we need to make sure enough heat can be delivered to the house and that the network has the capacity to do it. The building control will need evidence of both. When connected to a new district heat network, we need to calculate all the heat sources used up to the end of the year 2027. And when there is a change of the heat source, the building control will need to be notified of such, and the notification should consist of the planning permission if required and the contract for the new heat source. Swimming pools basins do not need to be treated differently, and no special consideration for the basins are used. The area of the pool should be treated as a floor with performance as that used for the creation of the pool. For the calculation U value for the party walls will be generally 0.0 for solid walls and fully filled cavity walls, and 0.2 for sealed unfilled cavity walls, and 0.5 for unfilled cavity walls. Fixed lighting will have an impact on the calculations of energy and emissions rates. To satisfy the requirements of target energy rate and emission rate, we need to follow the fabric efficiency combined with efficient building services integrated with zero carbon technologies, but only fabric efficiency when we deal with fabric energy efficiency rate. Now we are off to Regulation 25A that deals with consideration of high efficiency alternative systems. Let's start with the wording of the legislation. Consideration of high-efficiency alternative systems for new buildings. That's Regulation 25A.1. Before construction of a new building starts, the person who is to carry out the work must analyze and take into account the technical, environmental and economic feasibility of using high-efficiency alternative systems, such as the following systems in the construction if available. A. The centralized energy supply systems based on energy from renewable sources. B. Cogeneration. C. District or block heating or cooling, particularly where it is based entirely or particularly on energy from renewable sources. And D. Heat pumps. Point 2. The person carrying out the work must A. Not later than the beginning of the day before the day on which the work starts, give the local authority a notice which states that the analysis referred to in paragraph 1 point I has been undertaken, double I is documented, and triple I the documentation is available to the authority for verification purposes, and B ensure that a copy of the analysis is available for inspection at all reasonable times upon request by an officer of the local authority. Point 3. An authorized officer of the local authority may require production of the documentation in order to verify that this regulation has been complied with. Point 4. The analysis referred to in paragraph 1, point A, may be carried out for individual buildings or for groups of similar buildings or for common typologies of buildings in the same area, and B, insofar as it relates to collective heating and cooling systems, may be carried out for all buildings connected to the system in the same area. Point 5. In this regulation, A, cogeneration means simultaneous generation in one process of thermal energy and one or both of the following. I. Electrical energy. 2. Mechanical energy. B. District or block heating or cooling means the distribution of thermal energy in the form of steam, hot water or chilled liquids from a central source of production through a network of multiple buildings or sites for the use of space or process heating or cooling. C. Energy from renewable sources means energy from renewable non-fossil sources, namely wind, solar, aerothermal, geothermal, hydrothermal, and ocean energy, hydropower, biomass, landfill gas, sewage treatment plant gas, and biogases. And D. Heat pump means a machine, a device or installation that transfers heat from natural surroundings such as air, water, or ground to buildings or industrial applications by reversing the natural flow of heat such that it flows from a lower to a higher temperature. For reversible heat pumps, it may also move heat from the building to the natural surroundings. The Secretary of State is happy when we analyze the feasibility of such a system following Section 3. However, It is all about reasonable approach. There is no expectation of us using solutions that are not feasible at the moment. So what does section 3 say? It concentrates on the consideration of high efficiency alternative systems, which we need to have and have it documented for the inside of the building control. So just saying that you have considered it and it was not feasible will not suffice. This also applies to buildings under major renovations where the technical, environmental and economic feasibility of such a system needs to be evaluated. Now, to satisfy the requirement L1A in new buildings, we need to prevent the building from gaining or losing too much heat, which will be achieved by addressing building fabric, airtightness, pipework insulation, and in case of heat gain by following recommendations of section 4. In the case of the existing buildings and extensions, we need to follow recommendations of section 10, 11 and possibly even 12. Not make the airtightness walls and insulate the pipework. Section 4 deals with the limitation of heat gains and losses. Think U values and think about them in terms of the entire element and the way it is considered in the Building Research Establishment paper BR 443. U values for windows and doors can either follow the as-is configuration or a standard type as considered by the document or using the hotbox method to BSEN ISO 12567. Glass and Glazing Federation documents are also very helpful or use figures from sub-table 6e. The section gives us the limiting values for new buildings for different elements, but truth be told, these are lesser than the target values anyway, so will rarely be taken into consideration. On the other hand, limiting standards in existing dwellings for new and replacement element will be very much appropriate to use for roof that is 0.15 watts per meter squared Kelvin. For walls and floors it is 0.18, windows and doors are 1.4 and roof lights are 2.2. In case you are blessed with a swimming pool, it is 0.25 for the pool basin. But for renovated and retained elements that is less, and it will be different for retained elements and for renovated. A renovated element should reach the following: 0.16 watts per meter square Kelvin for roofs, floors at 0.25, cavity insulation at 0.55, internal or external insulation at 0.3, and retained elements should be upgraded to these values if they are over the threshold limits, and these limits are: for roofs 0.35, wall insulation and floor at 0.7. Naturally, this will not always be technically or functionally feasible or will lead to a simple payback or in the next 15 years. If such is the case, we will need to upgrade the element so it does satisfy these tests, but that is not less than the threshold value. It is important for the insulation to be continuous and tight to avoid unwanted cold spots, bridges or leaks of the heat and air carried moisture. To achieve this, we need to think about the proper specification that needs to be buildable, or in the other words, achievable on site. And once being built, it needs to be recorded that it actually is well executed in line with the specified details. Floors and foundations, perimeter insulation to be minimum of 25 mm, and the insulation under damp-proof course should be moisture resistant and extend to the foundation. Windows and doors should be tightly fit in line with BS 8213 and contiguous with the insulation layer. Insulated cavity closures are the way to go in cavity wall construction. Roof and wall insulation should overlap. Rigid insulation boards are known to be difficult to fit well, so there is a need to be of a compensatory measure, but in place like a compressible table for when the boards are placed in between the rafters, and low expansion foam in wall cavity. Any penetrations in the insulation should be addressed by ensuring a tight fit. Thermal bridging follows similar consideration for the insulation in general in terms of quality of the workmanship, specification for junctions and keeping of the as-built record. The emphasis falls on the continuity of the insulation or insulation elements, like having insulation under the damp-proof course of at least one block high, but to overlap with the insulation of the floor, and the same principle follows to windows and doors junctions, walls, floors, party walls and roof junctions. Thermal bridging should be assessed to BAR 497 to temperature factor set out in BREL information paper 1/06. or we are allowed to use other established details like these in the local authority building controls construction details library, but then inspection of the details on site will be paramount. We can also use the sub-values or a default values given by the document of 0.2 watt per meter square Kelvin. When we deal with the existing building, there are no special requirements, but to improve on the existing whenever possible. Airtightness in new dwellings should meet the minimum standards, but care needs to be taken to avoid unnecessary infiltration of cold or hot air. The drawing should show the position and extent of continuous air barrier. Any penetrations and junctions should be minimized and sealed. Airtightness in existing dwellings should be improved whenever possible, but care needs to be taken to address ventilation requirements of the entire dwelling, as such over-tightness may lead to condensation issues and combustible heating systems issues. Limitation of heat losses and gains from building services is another consideration of this document. The document basically tells us to insulate pipes where the loss of heat is the greatest, so where there is a hot water flowing and it flows through unheated spaces and voids, hot water pipes and secondary circulation pipes. Heat losses should not exceed limits. The limits put on us in the British standard 5422 for water at 60 degrees. The document gives us typical thicknesses for different pipes between 5 mm for a 10 mm pipe to 20 mm for a 100 mm pipe, and the size jumps by 5 every double, so 25, 50 and 100 mm pipes will have 10, 15 and 20 mm insulations around them. External district heat network pipes will also require appropriate insulation according to BSE and 253 for pre-insulated pipes or conventional equivalent of such, and at least as well insulated above ground as it is in ground. Hot water cylinder needs to perform to a certain maximum heat loss standards, which depends on their size, starting at 1.03 kilowatt hour per 24 hours for a 50 liter cylinder to 3.57 kilowatt hour per 24 hours for 1000 liter cylinder. There is an equation to follow if you need to go bigger. Similar limits are for heat interface units. Naturally, all type of water storage vessels will need to be up to the code, like BS 3198, specification for copper hot water storage combination units for domestic purposes, BS 15666 Part 1, copper indirect cylinders for domestic purposes, open vented copper cylinders, requirements and test methods, BSEN 12897, water supply specification for indirectly heated unvented storage water heaters. Moving on to the provision of energy efficient fixed building services with efficient controls, the Secretary of State is considered satisfied if the system meets minimum standards, is appropriately sized and has controls for hot water and heat. On-site electricity generation should also be properly sized and controllable. Now, Section 5 deals with general guidance for the minimum building services, efficiencies and controls. We are told that every new fixed building service needs to meet the minimum standards set in Section 6 for a given system. Services outside Section 6 should be treated in a comparable fashion with the one within. The efficiency needs to be tested and certified by a notified body. When we replace service in the existing house, we need to mind Section 6 efficiency, but otherwise provide service that is not lesser than the existing in terms of efficiency, when exchanging like for like, in terms of fuel, CO2 emissions and primary energy demand per kilowatt hours when changing the fuel type. There are some leeways on this provision, for example when we change to the heat pump of approved standard, or when we deal with a fuel change in a building that loses less than 25 kilowatt hour per meter square per year. Renewable heat sources should be changed like for like in terms of performance, and buildings should be ready to connect to a heat network. The proper sizing of the heating and hot water system should take in consideration the heat loss calculation for the dwelling and sizing methodology that accounts for the building's properties. The approved document preference, the Chartered Institute of Plumbing and Heating Engineering, Plumbing Engineering Services Design Guide for this purpose. Combi boilers should be able to modulate down their heat output to the level generally required by the dwelling. New wet heating systems need to be sized to meet the requirement of low temperature heating, so flow temperatures at 55 degrees Celsius maximum. That is also applicable to entirely new system in existing dwellings. This will not always be feasible, and whenever it is not, we need to size the system so it turns at the minimum that becomes feasible. Domestic hot water system should be sized in line with the need of the building and can follow BSEN 12831 Part 3 standards or the Plumbing Engineering Services Design Guide, and the system should not be significantly oversized. Heat pumps should be specified so they meet the needs of the dwelling without relying on additional electric heat being supplied to the system. Likewise, the reversible heat pipes should be optimized for heating rather than cooling. Now, controls of the system. We should consider splitting wet heating systems for new dwellings over 150 meters square. The system should switch off automatically if not in use. Hot water storage supply system should have electric temperature control and a time control that is independent of space heating circuits. Hot water circuits should have fully pumped circulation when it is compatible with the heat generator. Space heating should have temperature control for the heating appliance, and wet heating system should ensure minimum flow of water to avoid short cycling. Thermostatic room controls should be fitted in every room unless this is prudent to do otherwise or not feasible. The Secretary of State thinks it is prudent when at least 70% of the zone is an open plan living space or when a group of 2 adjacent similar use rooms are considered. We may satisfy the requirement of control by either thinking about the thermostatic control over each heat emitter, things like thermostatic radiator valve, thermostat in the room served by the given circuit, but do not provide both at the same time. Thermostat for individual rooms or heating zones or individual network heat emitter control for each emitter. When it comes to the control of the existing heating and hot water systems, it should follow the previous considerations, but if in the existing state both water and heating are controlled together, this may continue. The boiler interlock should be introduced if there is work done to the system with a boiler. Hot water cylinders, if replaced, should have an electronic temperature control, and the new boiler should have boiler controls in line with Section 6 expectations. Now, what is hiding in Section 6? In this section we come to find out more details about the expected performance of the systems installed in the dwellings, including for the energy generation. The document points us also to the Eco-Design for Energy-Related Products Regulation 2010, in case this also applies to our new system. The document gives us the minimum standards, but it may be the case that this minimum will need to be made better when considering the dwelling holistically. Starting with gas-fired heating systems, in new dwellings the wet heating should be at least 92% efficient to ERP efficient, but in the existing buildings this becomes convoluted and will be generally different for different types of heaters. So wet heating remains at 92% efficiency to ERP rating, but maybe as low as 78% to SEDB UK 2009. So we got 2 ways of measuring efficiencies, either to ERP or either to SEDBOK. Are the ways to measure. These are the ways to measure. ERP stands for Energy Related Products Directive, whereas SEDB UK SEDBOK stands for Seasonal Efficiency of Domestic Boilers UK. The data for all the other types of heaters can be read from the table in the document, and it includes for warm air heating, intended space heating applications, and inset live fuel effects heaters. There are also other aspects to consider, such like if we install a combi boiler in the existing dwelling, we should make its operation a bit more effective by either recovering the flue gas heat, making it measure the external weather and compensate for it with its load, or similarly compensating for the load in the system depending on the actual requirement of the dwelling. But I think the simplest one of them are simply smart thermostats. I personally have not seen one of these, but should you consider replacing or putting a new range cooker with an integrated gas boiler, the cooking and heating burners should be separate. Either gas-fired warmer systems or independent heating appliances should be controllable and automatically adjustable to the temperature of the space they serve. These appliances should meet appropriate standards like BSEN 12666, independent gas-fired convection heaters incorporating a fan to assist transportation of combustion air and or flue gases, BS 7977, specification for safety and rational use of energy of radiant convectors, BSEN 613, independent closed-fronted gas-fired type B11, type C11, type C31 and type C91 heaters, BSEN 13278, open-fronted gas-fired independent space heaters, BSEN 14829, independent gas-fired flueless space heaters for nominal heat input not exceeding 6 kilowatts, BSEN 449, specification for dedicated liquefied petroleum gas appliances, domestic flueless space heaters, including diffusive catalytic combustion heaters, and BSEN 509, decorative fuel effect gas appliances. Interestingly, we are not allowed to have more than one gas-fired fixed decorative effect fire per 100 meters squared installed in our dwellings. Now, off to oil-fired heating systems. The requirements are similar to that of gas heating system. We again deal with efficiencies either to ERP or setbook that are set within the document. Like for wet heating for regular boilers being 91 ERP or 84 setbook, and so on. Electric space heating system. These are considered 100% efficient, so no limits are given. For electric storage heaters, we need to be able to control the input charge as well as the heat release. Electric panel heaters or electric warm air systems also need control for each room or the appliance, but check the requirements of section 5 to not go too crazy on the amount of control. Solid fuel heating systems. These are by category designation and accordingly should have minimum efficiency measured in calorific value. Appliances forming part of the central heating system delivering primary heat belonging to either category D1 to 4, F, G2, J2 or J5 should meet the requirements of section 5, have separate time controls for space heating and hot water circuits, have automatic control of the burning rate and have factory required heat leak radiator installed. An appliance that is part of the central heating system should be one of the D, F, G or J categories and have the ratio of room heat to water heat set to be satisfactory to meet the needs of the property. District heat networks and community heating systems. The consideration of this part are for distribution networks of at least 15 dwellings that's with a central heat source, whatever that may be, boiler, combined heat and power unit or heat pumps. But whatever it is, if it is a new district heat network, it needs to comply with section 6 of the approved document L volume 2 dealing with buildings other than dwellings. Now, if we can connect the existing network depending if it's a new dwelling or an existing one, we will face different limits. So for the new dwelling, the emission factor for delivered heat should be under 0.35 kilograms per CO2 per kilowatt hour. You can get the value either from sub-calculation or the product characteristic database. The value should be the same as used in the calculation for the dwelling emission rate. Connecting the existing dwelling will usually mean changing the fuel source, so the appropriate paragraph of section 5 should be followed, but in the gist, it should improve the circumstance of the dwelling to be approved. The emission factor and primary energy factor for the house need to be established. The pumps of the system should have variable volume control to adjust to the requirement of the system and appropriate temperature difference for the primary heating circuit of at least 20 degrees Celsius for fuel heated networks. Heat pump network may work at lower differences. Dwelling input should be controlled with balancing valves and controlling maximum flow rate into the building. Wet heating system and by using the variable volume controls for the hot water system. All the heat exchange should be measured by appropriate meter for each dwelling. Now off to micro combined heat and power, called micro CHPs. It is important to ensure the micro CHP heating emission rate is not greater than that of the regular boiler using the same fuel as CHP. The emission rate should be established using DEFRA method or to evaluate the annual energy performance of micro generation heating systems in dwellings. BSIs past 67, together with the plant size ratio for the temperature difference of 24.2 centigrade measured heat output over heat loss of the building. Consideration for underfloor heating system are as follows. It should have temperature adjustable zones. If the system is electric, the room thermostat should have a manual override. Heating systems of four screeds greater than 65 mm thick should automatically reduce heating at night or when the room is not used, and the heat loss should be minimized in such systems. To minimize the heat losses, the floors should be insulated to limit the heat loss to not more than 10 watts per meter square, calculated by taking the U value of the floor times 10. We need to provide a separation between the heating system and the structure of the floor for at least 1.25 meter square Kelvin per watt of resistance to 1.25 R value for systems intended for intermittent or cyclical operation and or installed over unheated rooms. To reduce downward heat transfer and in intermediate floors, the layer of insulation should be at least the 10 watt per meter square or U value of 0.5 for electric systems or 0.75 for wet system. Distribution pipework should be installed insulated to the standards of section 4. For electric underfloor heating systems up to 60 mm thick, screeds are the direct system and the night storage systems are the ones with screeds 65 mm and over. If the night storage system is installed, we need to have a quick way of heating the house, and this should be able to hit at least 20% of the floor area of the dwelling and have control of the room thermostat and floor temperature sensing. In any case, a programmable thermostat with an override feature and floor sensing should be in place for the control of the operation of the electric system. Heat pump heating systems. As you know, heat pumps can be used for heating but also for cooling, and the cooling provision will follow later on. For heating though, they need to have certain efficiencies, and these are a minimum of 3 for heating and 2 for hot water. So they should be able to multiply the energy input of the system. If the system is small enough, under 12 kilowatts, the regulations for Eco Design Commission number 2016/2281 will apply. As ever, being an appliance heat pump will fall under the provision of section 5 considerations, but also we should be able to control the water pump, air or water temperature, fan operation, defrosting of the heat exchanger, secondary heating if fitted, and have protection from water and airflow failure, high water of refrigerant temperature. We should be able to control its operation with a timer or programmer for space heating and have weather compensation or internal temperature control fitted. If heat pumps are provided in addition to other heat sources, they all should be incorporated into one control system. The legislature reminds us about the placement of the heat pump and the importance of reading the manufacturer's instructions. The most troublesome aspects of the wrong placement will be the falling effectiveness of the pump, problems with the recirculation of cold exhaust air, and removal of condensation from the outer cold during the frosting. Nuisance from the use, noise and vibration can also be a problem, so we need to think about these where to be placed and how to mitigate it, and we will also be bound by planning regulation on this front. Solar water heating systems. The document considers systems where the solar collectors is less than 20 meters squared, which supplies a storage tank of not more than 440 liters. The system needs to be tested to BSEN 12975 Part 1 and BSEN ISO 9806 for thermal performance and documentation. The pump for the collector should be less than 50 watts or 2% of the peak thermal power of the collector. The ratio for the heat exchanger area and the absorber should be 10. The system should be controlled so that the use of solar power is maximized and used first before boosting by other heat sources, as well as to mitigate on adverse effects of excessive temperatures and pressures. The hot water storage vessel should be at least either 25 meters square for every 1 meter square of the net absorber area or 80% of the daily hot water need for the dwelling. Comfort cooling. The cooling system should be based on the heat gain calculations for the dwelling and not be over 120% of the cooling load. We can calculate the load using CIBSE BSE Guide A and the manufacturer's data. The seasonal energy efficiency ratio of the unit should be 4 or more. Control for the timing and temperature should be provided for each control zone and terminal unit, and if the heating is provided for the room, they should be prevented from working simultaneously. The refrigeration pipework should be insulated and in protective trunking. Cooling systems serving more than one dwelling should follow the recommendations of Volume 2 of this document. Now, mechanical ventilation. We heard this one before when we discussed the ventilation requirements for the dwellings. So we know how to ventilate already, but now we cannot use too much energy to achieve it. So we are faced with efficiencies here also. Units extracting the air intermittently or continuously should have an efficiency of 0.5 watt per liter per second and 0.7 watt per liter per second. Continuous supply should be at 0.5 watts per liter per second, and combination of extraction and supply should have heat recovery system for at least 73% efficiency, but bypassable and controllable during summertime, and using no more than 1.5 watts per liter per second. Lighting. The space should not be overly illuminated, but you will buy your own light bulb, won't you? The efficiency of the lamp should be at 75 lumens per watt. Lamps should be functional for the space or zone and controllable. External lighting will need to be automatic for people and daylight if the efficiency is worse than 75 lumens per watt. Otherwise, manual control is fine. Building automation and control systems. The document does not really go into too much detail apart from requiring it to be proper, and if the building is large and complex, the Volume 2 consideration may be put in place. When it comes to on-site electricity generation and storage, it needs to be sized properly for the site and demand, follow manufacturer instructions. If replacing an existing system, the efficiency and capacity should be as that existing unless the dwelling's needs can be satisfied. The system should control itself automatically. So off to section 7, which deals with the requirements of Regulation 43, pressure testing. Let us start with the text of the legislation. Pressure testing, Regulation 43.1. This regulation applies to the erection of a building in relation to which paragraph L1AI of Schedule 1 imposes a requirement. Point 2. Where the regulation applies, the person carrying out the work shall, for the purpose of ensuring compliance with the Regulation 26 and Regulation 26A and paragraph L1AI of Schedule 1, A. Ensure that I. Pressure testing is carried out in such circumstances as are approved by Secretary of State, and I. The testing is carried out in accordance with a procedure approved by the Secretary of State, and B. Subject to paragraph 5. Give notice of the results of the testing to the local authority. Point 3. The notice referred to in paragraph 2b shall A. Record the results and the data upon which they are based in a manner approved by the Secretary of State, and B. Be given to the local authority not later than 7 days after the final test is carried out. Point 4. A local authority are authorized to accept as evidence that the requirements of paragraph 2a have been satisfied a certificate to that effect by a person who is registered by Elmhurst Energy Systems Limited or the Air Tightness Testing and Measurement Association in respect of pressure testing for the air tightness of buildings. And point 5, where such a certificate contains the information required by paragraph 3a, paragraph 2b does not apply. The Secretary of State is happy if the dwelling passes the pressure test as described further in this section. The test should be done on each and every dwelling. The maximum rate of air leakage limit at 50 pascals needs to be established using properly calibrated equipment by a trained and registered individual. The building control will require proof of the test certification, calibration and individual credentials. The energy rate, dwelling emission rate and fabric energy efficiency rate should be recalculated using the test results to check if this meets the target. The report on test attempts should be included in the building control submission, so the failures go in as well. The test should be done to CIBSE TM23, testing buildings for air leakage. Now section 8 deals with commissioning and regulations 44 and 44ZA, starting with the legislation. Regulation 44, Commissioning. Point 1. This regulation applies to building work in relation to which paragraph F1.2 of Schedule 1 imposes a requirement, but does not apply to provision or extension of any fixed system for mechanical ventilation or any associated controls where testing and adjustment is not possible. Point 2. This regulation applies to building work in relation to which paragraph L1b of Schedule 1 imposes a requirement, but does not apply to the provision or extension of any fixed building service where testing and adjustment is not possible or would not affect the energy efficiency of that fixed building service. Point 3. Where this regulation applies, the person carrying out the work shall, for the purpose of ensuring compliance with paragraph F1.2 or L1b of Schedule 1, give the local authority a notice confirming that the fixed building services have been commissioned in accordance with a procedure approved by the Secretary of State. Point 4. The notice shall be given to the local authority a. not later than the date on which the notice required by Regulation 16.4 is required to be given, or b. where that regulation does not apply, not more than 30 days after completion of the work. Commission in respect of a system for on-site electricity generation, that's Regulation 44 ZA. Point 1. This regulation applies to building work in respect of a building in relation to which paragraph L2 of Schedule 1 imposes a requirement, but does not apply to the provision or extension of any system for on-site electricity generation where testing and adjustment is not possible. Point 2. Where this regulation applies, the person carrying out the work must, for the purpose of ensuring compliance with paragraph L2 of Schedule 1, give to the local authority a notice confirming that the system for on-site electricity generation has been commissioned. Point 3. The notice must be given to the local authority a. not later than the date on which the notice required by Regulation 16.4 is required to be given, or b. where that regulation does not apply, not more than 30 days after completion of the work. In the gist, fixed building services need to be commissioned to assure the operation is good and proper. This involves the formation of commissioning plan that identifies what is being tested and how, and what does not require testing and why. It forms part of your submission to building control. Notice of completion will generally follow the 5-day requirement upon completion, but could be up to 30 days when done by a person registered in the competent person scheme. It will need to include confirmation of following the proper procedures, including the commissioning plan and giving assurance of reasonable performance. It is rather pertinent to have that notice done, as building control may withhold the completion certificate until it is. Now, going system by system. Hot water system should be prepared and commissioned to BS 7593. The system should be cleaned and flushed out. Include chemical inhibitors in the primary heating circuit to protect against scale and corrosion. In hot water areas, we may need to treat the water to maintain the system. Heat pumps should be commissioned to manufacturer specs and systems design parameters. Ground arrays should be flushed and purged to get rid of debris and air. That flushing should be separate to the heat pump system, which will require the same in isolation from the array. Cleaning and purging should be followed by a pressure test to BSEN 805. Antifreeze and biocide should be added to the heat exchangers as appropriate. Commissioning information needs to be provided to the dwelling owner and should include the details of the fluid and its commissioned concentration. For community heating system, they should be commissioned to optimize the use of energy for pumping and the flow rates. Individual heat emitters should be balanced either using calibrated control valves or appropriate return temperatures. Underfloor heating commissioning should be done to BSEN 1264 Part 4. Section 9 covers the necessity of providing information about the system, including in Regulation 40 and 40A, starting with the text of the legislation. Information about the use of fuel and power. Regulation 40. Point 1. This regulation applies where paragraph L1 of Schedule 1 imposes a requirement in relation to building work. Point 2. The person carrying out the work shall not later than 5 days after the work has been completed provide to the owner sufficient information about the building, the fixed building services and their maintenance requirements so that the building can be operated in such a manner as to use no more fuel and power than is reasonably in the circumstances. Requirement 40A Information about systems for on-site generation of electricity. Point 1. This regulation applies to building work in respect of a building in relation to which paragraph L2 of Schedule 1 applies. Point 2. The person carrying out the work must not later than 5 days after the work has been completed provide to the owner sufficient information about the system for on-site electricity generation in respect of its operation and maintenance requirements so that the system may be operated and maintained in such a manner as to produce the maximum electricity that is reasonable in the circumstances and delivers the electricity to the optimal place for use. In the gist, the owner needs to know how to operate and maintain the system and what work has been done. The operating and maintenance instructions should be easy to understand, site-specific, detailed and accessible. They should describe the system with its location on the floor plan, identify components and explain their function, how to operate and maintain them, direct us to important documents and include commissioning sheets where relevant. In addition, new buildings should have an accompanying BREL report with photographic evidence of the build quality and all the as-built energy pertinent data as well as the energy performance certificate together with recommendations. Home user guide should accompany new dwellings and contain provisions for ventilation, heating and domestic hot water, on-site electricity generation, staying cool in hot weather. In existing buildings, if Section 5 and or 6 apply, the installation or the fixed building service should be energy performance assessed and documented. When it is the whole system, we will comply by either providing the full record of commissioning to Section 8 requirements or the sub-assessment, EPC certificate or similar. However, if work on the existing system alters energy performance or CO2 emissions of the system, work like changing heating fuel or increasing the system capacity by 25%. Section 10 deals with the elements in existing dwellings including extensions. In addition to the requirement L, we need to also consider regulation 23.2, and the text of which is requirements for the renovation or replacement of thermal elements, requirement 23.2, where the whole or any part of an individual thermal element is proposed to be replaced and the replacement A constitutes a major renovation, or B, in the case of part replacement, amounts to be replacement of more than 50% of the thermal element surface area, the whole of the thermal element must be replaced so as to ensure that it complies with paragraph L1AI of Schedule 1, insofar as that is technically, functionally and economically feasible. In the gist, the building fabric will need to satisfy the performance given in Table 4.2 for all new and replaced elements. The opening areas in the fabric of the building should be kept within the 25% of the floor area limit unless some compensation measures are being introduced to increase the overall energy efficiency of the dwelling. Windows and doors may satisfy the performance with appropriate certificates and will fall under the consideration when the work applies to the controlled fitting, meaning including the frame of the element. When such controlled fitting is changed, we also need to think about draft proofing and installing cavity closures should that be appropriate. For extensions, similar expectations are put, and following Table 4.2 for new and replacement elements and Table 4.3 for adopting the existing should be our first point of check. The total area of openings in such extended spaces is again 25% plus all the openings that no longer exist due to the creation of the extension. Fixed services and the extension should as ever follow Section 5 and 6 requirements. The openings can also be justified by comparing the area weighted U value of the one that follows the 25% plus existing opening consideration. Simply add all elements areas times their U value and divide them by the sum of all these areas and compare the results, or we can also use sub-calculations for the entire building plus the notional extension. When it comes to conservatories and porches, this may be treated separately from the dwelling if they are separated by the thermal elements from it and the heating system is not extended to them. If they are not excluded from the energy efficiency requirements due to exceeding a certain size and location, should have thermal elements of sufficient performance and separated separate control of the services within. There is no limit on the amount of glazing for such conservatories and porches. Now, Regulation 6, Regulation 22 and 23.1 deal with material change of use and change to energy status, starting with and let's start with the text of legislation. So the Regulation 6, requirements relating to material change of use. Point 1. Where there is a material change of use of the whole of a building, such work, if any, shall be carried out as is necessary to ensure that the building complies with the applicable requirements of the following paragraphs of Schedule 1. A. In all cases, B1, means of warning and escape. B2, internal fire spread linings. B3, internal fire spread structure. B4.2, external fire spread roofs. B5, access and facilities for the fire service. C2C, interstitial and surface condensation. F1, ventilation. G1, cold water supply. G3.123, hot water supply and systems. G4, sanitary conveniences and washing facilities. G5, bathrooms. G6, kitchens and food preparation areas. H1, foul water drainage. H6, solid waste storage. J1 to J4, combustion appliances. L1, conservation of fuel and power. P1, electrical safety. S2, infrastructure for the charging of electric vehicles. B, in the case of a material change of use described in Regulation 5C, D, E, or F. A1 to A3, structure. C, in the case of building exceeding 15 meters in height. B4, 1, external fire spread walls. D, in the case of a material change of use described in Regulation 5A, B, C, D, G, H. I, or where the material change provides new residential accommodation. F, C1.2, resistance to contaminants. E, in the case of a material change of use described in Regulation 5A, C2, resistance to moisture. F, in the case of material change of use described in Regulation 5A, B, C, G, H, or I. E1 to E3, resistance to the passage of sound. G, in the case of material change of use described in Regulation 5E, where the public building consists of or contains a school. E4, acoustic conditions in schools. H, in the case of a material change of use described in Regulation 5A or B. G2, water efficiency. And G3.4, hot water supply and systems, hot water supply to fixed baths. I, in the case of a material change of use described in Regulation 5C, D, E, or J. M1, access to and use of buildings other than dwellings. J, in the case of material change of use described in Regulation 5A, B, or G. Q1, security. 2, where there is a material change of use of part only of a building, such work, if any, shall be carried out as is necessary to ensure that A, that part complies in all cases with any applicable requirements referred to in paragraph 1A. B, in a case in which subparagraph B, E, F, G, or H, or paragraph 1 apply, that part complies with the requirements referred to in the relevant subparagraph. C, in a case to which subparagraph C of paragraph 1 applies, the whole building complies with the requirement referred to in that subparagraph. D, in a case to which subparagraph I of paragraph 1 applies. I, that part and any sanitary conveniences provided in or in connection with the part comply with the requirements referred to in that subparagraph. And I, the building complies with requirement M1A of Schedule 1 to the extent that with reasonable provision is made to provide either suitable independent access to that part of or suitable access through the building to that part. E, in a case to which subparagraph J applies in respect of material change of use described in Regulation 5B or G, that part complies with the requirement referred to in that subparagraph. Point 3. Subject to paragraph 4, where there is a material change of use described in Regulation 5K, such work, if any, shall be carried out as is necessary to ensure that any external wall or specified attachment of the building only contains material of European classification A2, S1, D0, or A1, full stop. Classified in accordance with BSEN 13501 Part 1 2007 plus Appendix 1 2009. entitled Fire Classification of Construction Products and Building Elements, classification using test data from reactions to fire test, ISBN 9780580598616, published by the British Standard Institution on 30th March 2007 and amended in November 2009. Point 4. Paragraph 3 does not apply to the items listed in Regulation 7.3. Now off to requirement 22, relating to a change to energy status. Where there is a change to a building energy status, such work, if any, shall be carried out as is necessary to ensure that the building complies with the applicable requirement of Part L of Schedule 1. And requirement 23.1, where the renovation of an individual thermal element, A, constitutes a major renovation, or B, amounts to the renovation of more than 50% of the element's surface area, the renovation must be carried out so as to ensure that the whole of the element complies with paragraph L1AI of Schedule 1, insofar as that is technically, functionally and economically feasible. Secretary of State is satisfied the requirement 6, 22 and 23.1 are met if we follow the recommendation of Section 11. And Section 11 covers work to elements of existing dwellings, work understood as renovation of an existing thermal element, material change of use and change to energy status. The consideration does not follow new and replacement elements. That was covered in Section 10. So what is considered a renovation? It is providing an additional layer in the build-up of the elements, so cladding, rendering or dry lining, and replacement of the layer by stripping down to structural components, replacing waterproof membrane on a flat roof, providing cavity wall insulation. This, however, follows limits of impact, so to exclude minor maintenance jobs. The limits are as follows: 50% of the surface of the individual element is renovated, so a wall, a roof or a floor, or 25% of the surface area of the external building envelope is renovated, all elements combined. If our work falls under any of these two, we will need to upgrade the whole of the renovated element in line with Table 4.3 of the document and Table C1 in Appendix C. Now, we consider material change of use if we turn buildings into dwellings or flats, or change the number of dwellings, and we consider the change to energy status when the space is turned into space which falls under energy efficiency requirements. So when we change the space, we need to think about the limiting factors for thermal elements, which were previously discussed and are contained within Section 4. If the opening in thermal elements are between external and conditioned spaces, they need to be assessed, and if they exceed the U-value limits, they will need to be replaced. The limits are 3.8 watt per meter square Kelvin for roof lights and 3.3 watts per meter square Kelvin otherwise. In addition to following Section 4 recommendations, we need to consider openings to be no more than 25% of the floor area and services, and their control to Section 5 and 6 recommendations. Alternatively, if the building contains more than one dwelling, we can use sub-procedure to establish the dwelling's primary energy use and total CO2 emissions from all dwellings, and it may be better than simply following the previous guidance. That leads us to Regulation 28. In legislation it says consequential improvements to energy performance, Regulation 28.1. Paragraph 2 applies to an existing building with a total useful floor area over 1,000 meters square, where the proposed building work consists of or includes an extension, the initial provision of any fixed building services, or an increase to the installed capacity of any fixed building services. Point 2. Subject to paragraph 3, where this paragraph applies, such work, if any, shall be carried out as is necessary to ensure that the building complies with the requirements of Part L of Schedule 1. And point 3. Nothing in paragraph 2 requires work to be carried out if it is not technically, functionally or economically feasible. And that's covered in Section 12. It deals with consequential improvement of large dwellings of over 1,000 meters squared of useful floor area, or what is otherwise also called gross floor area. We are basically told that we may need to upgrade the overall energy efficiency of the dwelling if we extend it, provide fixed building service, for the first time or increase the capacity of any fixed building service, and this does not include renewable energy. Naturally, this improvement needs to be technically functional and economically feasible. For technical guidance, we are sent to the volume 2 of this approved document, which will be covered in the next episode. So this is it, folks, the approved document L, Conservation of Fuel and Power Volume 1, Dwellings. Let's sum it up section by section. So Section 1 outlines the process of calculating the total energy performance for new dwellings by comparing them to a notional dwelling using the Standard Assessment Procedure SAP. Key metrics include the target primary energy rate, target emission rate, and target fabric energy efficiency rate, with specific requirements for thermal fabric, ventilation, heating systems, and lighting. For buildings with multiple dwellings, these targets are averaged based on floor areas. Section 2 covers the calculation of actual energy performance metrics for a dwelling, including primary energy rate, emission rate, and fabric energy efficiency rate, which must be compared against target values. These calculations required before and after construction are documented in BREL report and submitted to building control, including any adjustments for additional heating sources or heat networks. Special considerations include U values for different wall types and the impact of fixed lighting, with a focus on integrating fabric efficiency and low carbon technologies to meet energy and emission targets. Section 3 says that before starting construction on new buildings, an analysis of the feasibility of using high-efficiency alternative systems such as renewable energy, cogeneration, district heating or cooling, and heat pumps must be conducted, documented, and submitted to the local authority. This analysis, which must be available for inspection, applies to individual or groups of buildings and includes both new constructions and major renovations. The key requirement is documented, and reasonable consideration of these systems should be there, regardless of whether they are ultimately implemented or not. Section 4 outlines the limitation on heat gains and losses in buildings, emphasizing U values for various elements, walls, roof, floors, windows, and doors, and the importance of continuous insulation to prevent thermal breaching. It specifies minimum U values for new and existing dwellings with stricter standards for renovated and retained elements, and requires that airtightness and proper insulation be maintained to meet energy efficiency standards. Section 5 mandates that all new and replaced building services meet minimum efficiency standards and be appropriately sized, with a focus on low temperature heating systems and controls to prevent energy waste. The system should be designated to match the specific heating and hot water needs of the building, with controls such as thermostats and timers to optimize performance. In existing buildings, efficiency upgrades should adhere to these standards, ensuring that heating and hot water systems are not oversized and are equipped with proper controls to enhance energy efficiency. Section 6 outlines detailed performance standards for various heating, cooling, ventilation, and energy generation systems in dwellings. It emphasizes the need for high efficiency in new and existing systems, with specific requirements for gas, oil, electric, and solid fuel heating, as well as heat pumps, solar waste heating, solar water heating, and comfort cooling. Each system must meet or exceed minimum efficiency standards, be appropriately controlled, and be sized according to the dwelling's needs. Additionally, the section covers consideration for district heating, underfloor heating, mechanical ventilation, lighting, and on-site electricity generation, ensuring all systems operate efficiently and effectively within the building's overall energy framework. Section 7 mandates pressure testing for all new dwellings to ensure compliance with regulations on energy performance, specifically limiting air leakage. Tests must be conducted by certified professionals using calibrated equipment, with results submitted to building control within 7 days. Compliance is confirmed through recalculating energy, emission, and fabric efficiency rates based on the test outcomes. Section 8 mandates the commissioning of fixed building services and on-site electricity generation systems to ensure proper operation and compliance with regulations. A commissioning plan detailing the test procedure must be submitted to building control with a notice confirming completion required within up to 30 days. Specific systems like hot water, heat pumps, community heating and underfloor heating must adhere to these designated standards and procedures, including system cleaning, flushing and appropriate chemical treatments. Section 9 requires that within 5 days of completing building work, the owner must be provided with clear, detailed information about the operation and maintenance of the building's fixed services and any on-site electricity generation systems. This information must include system descriptions, maintenance instructions and commissioning details, with new buildings also requiring a BREL report and energy performance certificate. For existing buildings, any significant changes affecting energy performance or CO2 emissions must be documented and assessed according to relevant standards. Section 10 mandates that any new or replacement thermal element in existing dwellings must meet performance standards outlined in Table 4.2, with major renovation or replacement over 50% of an element's surface area requiring full compliance with these standards, as far as technically and economically feasible. Extension must adhere to similar performance criteria and ensure that the total area of openings does not exceed 25% of the total floor area, with specific attention to fixed services and their extensions. Conservatories and porches can be treated separately if they have their own thermal elements and controls, but must still meet performance requirements if they are integrated into the main dwelling. Section 11. When a building undergoes a material change of use, renovation or energy status change, it must comply with applicable requirements of Schedule 1, including energy efficiency and thermal performance standards. Major renovation or replacements of over 50% of thermal element surface area must meet updated performance criteria. Additionally, for energy status changes, compliance with Part L requirements is necessary, and in case of multiple dwellings, sub-procedures may be used to assess overall energy use and CO2 emissions. Section 12 for existing buildings over 1,000 meters squared. Any work involving extensions, new fixed building services or increases in service capacity must ensure compliance with Part L requirements, provided it is technically, functionally and economically feasible. This rule does not apply to renewable energy installations. Further technical guidance is detailed in Volume 2 of the approved document. In the next episode, we will move to approved document L, Conservation of Fuel and Power Volume 2, Buildings Other than Dwellings. I hope you enjoyed this episode and that the considerations of the approved document L, Conservation of Fuel and Power Volume 1, Dwellings, are clear for you now. If you have any questions, reach out to me on LinkedIn or send me an email. I'm more than happy to help you out. In BITNA, we deal with planning, designing and managing of your projects, and we are always glad to facilitate a free initial consultation to steer you in the right direction. Visit www.bitnar.co.uk and reach out to us. Whether your question is if we can help you with your project or what should I do, we will be able to give you a piece of non-obligatory advice. At BITNA, we help our clients design and execute their dream homes or investments. If your building is falling apart, we can also help investigate the reasons behind it and to provide you with an appropriate strategy, design and specifications for the repair. Thank you again for listening. Please voice up your opinions. I'm waiting for you on LinkedIn and I want to hear from you. See you next week. BITNA designs the world around you. Toodaloo.